Hi, how are you doing?
I'm good. How are you?
Good, thank you. Let me pin you or make you co-host.
Cool. Oh, I can make your background cool. Okay, so I'm going to change your name.
Hi, everybody. We'll start in a few minutes. Just stop. Go lie down. Go lie down. Okay, so we are going to go ahead and get started. This week we are finishing the course. This is the last part of the course. Next week we're going to begin CIS824C. Okay, so I'm going to go into screen share. I will show you what we're going to be doing today. So in this week, we are going to finish up with protocols, routing, and some troubleshooting techniques. The notes is a little bit longer because I tried to add in as much as I can so you will know. Who is not on mute? Okay, so I will go over the things that we have to do today. Today we are going to do the in-class assignment. I'm going to reserve some time at the end for you to do the lab. There's the extra credit review game for this week. So if you like, you can participate in that. With that, you can earn 20 points for extra credit, and it can be added to your deficient area of the grade. And then we will have a quiz, which is a short quiz, so you can complete that. And if you like, you can also earn an additional 20 points for doing the course survey. There are 2 surveys to be completed. RCCD, or Moreno Valley College, probably sent you a survey today to evaluate me as an instructor. I am going through my review for the year, so I appreciate it if you can complete your survey today or this week. This is for the course survey, which is in Canvas. And basically, I want to get your feedback so that way I can redesign the course for future students. So to get the extra credit, you can complete this survey and also the extra credit game in quizzes. But please complete the survey in your email. That's from the college. And in November, I will be meeting with the dean and the chair to go over my performance. So if you can download the notes for the week and the assignments, I will go over those. It says, you can't access the modules until the survey is completed. Hold on, let me check to see. Yeah, so the link that I put in here in the extra credit is a Google link. And that is my own survey. Oh, the school survey. Okay. Yeah, so I guess they wanted us to complete this week. So yeah, sometime next week, if you can complete the survey. I won't be able to see anything until after everybody posts. That's something on the school end, but I will ask and find out. Okay, so I'm going to go over the concept for this week. And if you have any question, I will periodically check the chat, but you can also unmute and ask. That will be fine, Daniel. So yeah, so we have until Tuesday to get everything closed out. So I open everything until October 20th. If you have any outstanding assignment in the past week, make sure that you complete them. I think those get closed out. The earlier assignment gets closed out by Sunday or Monday. But in the case that they lock, I'm going to change that so that way it will be open until Tuesday. This week, everything needs to be completed by Tuesday so I can upload your grade to WebAdvisor. And my grade is due the next day. So I hope to get everything done and ready before Thursday. Okay. If you have any question, you're welcome to email me, or you can even pop in my office hours on Monday, Tuesday, or Wednesday throughout the week. Okay, so in this week, we're going to talk about protocols, as I mentioned in the past. Protocols is essential, especially when we work with securing the system. So that's going to move us into the next part. Also, it's important in networking because this is how we can establish communication across our systems. So to redefine protocols, we touch a little bit on a few protocols. We talk about DNS, DHCP, but I want to go over it a little bit more today. So protocol is a set of rules. It's a way that we can format and process data. And our rules is going to be used in different type of systems, including your switches, routers, and your servers. So it's a way that we can establish a standardized set of rules so that way it would work across all different systems, and so we can establish what we see as internet. So in the set of protocols, I only list the common one that you would see in our network environment. There are many others. And as you go into the security class, you would see that we will talk about protocol would work with cryptography. And some of the protocols been established since the 70s, so there are some weaknesses in the protocol, and we do see that in the security. So Telnet, this is a way that we can terminally connect to another system or communicate with another system. So in the 80s and the 90s, people used Telnet, which is port 23, to connect to the client machine, another computer. And it's a way that we can access the resources. So in the past, Telnet was used to interact with another system. Now, the challenge with this today is that Telnet creates issues for security as it opens that session and it's not secure. So if you enable Telnet on your network or on your computer, potentially somebody can attack you using Telnet. So this protocol was later replaced by Secure Shell. And using Secure Shell, you can use a different an application to access it. I can use Secure Shell to connect to a switch or a router. I can use Secure Shell to establish an encrypted communication session with another system. Then up until today, we also use a file transfer protocol. This is called FTP. And it uses servers to be able to distribute files, such as we can use it to download files, we can use it to upload files and share files across the internet. So this is being used with your IP network. Now, you want to use Secure File Transfer Protocol instead of the regular FTP, which is port 22. There are only approximately 2,000 common ports. The ones that we see are the common ports, which is a number that's given to specific protocol for services. So Secure Shell uses also port 22, and SFTP, Secure FTP, also uses port 22. So what you should do when you're downloading files from file servers across the internet, you can enable port 22 on your router and enable that protocol for the service. People don't use file server as much as they used to back in the day, but in a company, they might have a file server to distribute to users, or they can use an intranet, which is connect to a web server, so people can authenticate putting in the username and password and be able to access the files. And now you notice that some of the protocol uses TCP and some of the protocol uses UDP. The difference between the ports that are using TCP is that it needs to have the acknowledgement that data has arrived and it's delivered. Compared to UDP, it will just open as it arrives and there's no guarantee. So compare the SFTP to the TFTP, right? TFTP would be faster. However, secure file transfer protocol will be more secure. It will be more protected. So now there's some differences with the ability between the two. So you do see some implementation of both in different networks, depending on the objective. If we need something that's fast, that's easy, and contain no directory, we would use the TFTP. So now we know that everybody access email. So whenever that you access your RCCD student email, what you're using is you're using a mail server that's transferring, or it is a transfer agent to bring email to your mailbox. And on that server, it uses SMTP, stands for Simple Mail Transfer Protocol. So this is a way that we can queue messages on the server. And Riverside Community College uses Microsoft product. So on the Microsoft Exchange server, it uses SMTP. So when you configure the mail server like Exchange, you have to enable, right, the capability for it to utilize SMTP. And Microsoft built that into their installation wizard, which is incorporated as a software for that particular server. Now, the user yourself, when you retrieve mail, especially from Gmail, Outlook.com for school, or even AOL, Yahoo, you're using POP. That's called the Post Office Protocol. And the current version we're using is version 3. And this uses port 110. So everybody that uses
if you find yourself on level 200, there will be a lot less people above you eating the food, so you won't starve. Now, if the BSC has a large backlog of applicants, this will throw a giant wrench in the plan. Wait it out. If you only have a few months in
So when you're using your email on the web, you're using POP3. Now, Imap is also a protocol that's used for email. So when you're getting a preview of your email in your mailbox, that would be using Imap. Imap specifically uses mail header, and it would download part of the message only to show you a preview of the mail message. So whenever you see that popping up on your phone or even on your mailbox, when you access your mailbox, you will see a preview of that mail that's using Imap. And the current version we're using is version 4, and that uses port 143. Okay. So let's touch on some of the questions. In question 1, it asks you, transferring file between two computers across the IP network in a non-encrypted session. That is, we're using FTP, file transfer protocol, and it's port 20 and 21. So this protocol can use 2 ports, 20 or 21. Now, if you're taking the certifications like Network Plus, you have to know the protocol, its functionality, and the port number. Security Plus does the same thing. It asks the same thing. For the server email delivery in a network, we use Simple Mail Transfer Protocol, port 25. So the administrator would need to enable that port to be able to transfer email to different mailboxes for different users. And then if we're retrieving web email, client system connect to web email servers to access email inbox, trash, sent folder, etc. That uses POP3, Post Office Protocol version 3. And it utilizes port number 110. This is just a value that's given to that specific protocol. And we want to utilize that value to control, right? We can even block a certain protocol using systems, and we can specify the port number. You will see that in your lab this week. For Internet Message Access Protocol, that is used for D, client system downloading or searching email using headers. So when you're searching for a sender, right, in the search bar for your webmail account, you are using Imap. For E, when you remote into another system using Microsoft Windows, you use a built-in protocol called Remote Desktop Protocol. Everybody that uses Windows environment uses RDP. So if I need to remote into your computer, I would enable RDP and I would put in your public address, but you have to allow me to connect. And you can set up the session to be for a block of time. So let's say you need to help your friend install an application. You can do that. Now, just to show you real quick. So if you just simply type in remote desktop connection on your Windows 10, it shows this. And I'm using not professional version, I'm using the home version. So basically you can specify the domain or the public address of that system. However, the receiving end, your friend's computer, needs to allow you to connect. Otherwise, it won't let you connect. So on this one, you see that I previously taught CIS 25 and 27 using some component on AWS. Amazon cloud. So I would specify that server here, and then I have to enable it on the Amazon cloud so I can connect. It's a way that we can see the other desktop by connecting it, or we can see the other systems resources. Okay. So that's RDP, and it uses a higher port number, 3389. Sarah asked, is that approval or connection called handshaking? It does do the handshaking through TCP, that it has to acknowledge there is a connection and it's ready to receive. But RDP on top of that is going to really look at the session time, the allowed, and the direct communication between two systems. So it's RDP, when it runs on top of TCP, it already established the connection acknowledgement at that point. Okay. So you have to enable this port and enable the protocol in order for it to communicate. So when you log in to a website to pay your bill, to access your bank account, to download your bank statement after you authenticate, anytime that you utilize the web with authentication to make a purchase, etc., you're using a protocol called TLS. Before, we used to use SSL, which is called Secure Socket Layer. And about 11, 12 years ago, they found that there is a heartbleed problem, which is a weakness in the protocol code. So an attacker took the advantage of the weakness and be able to attack many different websites. So what happened was they had come back and they had updated the version for the SSL. But after that, the industry just moved over to use TLS, which is usually coupled with SSL, but it is a better suite of protocol for web data transfer. So when you're using like Instagram messaging, when you're using web authentication to access web resources, you really, in the front, it's using TLS. And then we would couple that with other cryptography type protocol to be able to make sure that your session is secure. Okay. And so this uses port 995 for TLS. And it also, for SSL, it uses 465. Now, there are still websites that are still using SSL, and not everybody has completely transitioned even after a decade. However, recommended that TLS is being implemented, and it's a much better protocol compared to its cousin SSL. Okay. Then next, we're going to talk about the communication session for voice and video, what we're using right now, right? So how your video and your audio is constructed and deconstructed. So when I'm talking and when I'm moving, when there's image of me, it arrives on your computer and it needs to, so first it has to deconstruct when it sends as data packets. When it gets to your system, even if you see it close to life, right? What it has to do, it has to reconstruct that packet so you can hear me and you can see me. So this uses a protocol use SIP. It's used Session Initiation Protocol. And we can utilize both TCP or UDP. And often for media, they opt to use UDP because it's faster. Okay, it just opens as it arrives. It doesn't have to wait for the entire packet order, right? Like we talked about the bicycle. So with UDP, is it's just going to open, it's going to see the pedal, and it's going to give you the pedal. Now the TCP, it opens all the components and it rearrange everything back into like a bicycle, and then it presents it to you. So there is a little bit slower, but it's definitely more complete. So SIP is used for video conferencing, streaming multimedia distribution like Netflix, instant messaging, especially when you're doing more on the video side, like if you're using your iPhone to do that, or if you're using, other product. So definitely Zoom is using SIP. Then G and or H, we have a protocol that we use to gather information of all the connected system to determine their health, right? Their connectivity. And that is the Simple Network Management Protocol, your SNMP. This is used for network monitoring tools. It's used also in security appliances to detect system connectivity and the services that are running on those systems and the resources. So that uses UDP 161 as port. And we have the upcoming time change. So for us, when we go through time change, the network that you connect to, like Verizon, AT&T, T-Mobile, they update the time on their system, which is their server and all their communication appliances, which push the updates to your smartphone, right? If you connect to Spectrum, Frontier, they also do the same thing. And this protocol was created by a professor at one of the university. I showed that in the notes. It's called Network Time Protocol. It was originally implemented not just for the user to see the synchronized time, but when we do batch file, for example, when you submit transaction in your bank account, let's say you make purchases, you transfer funds, you pay your bills, those transactions don't always occur right after it was processed. Most financial institutions, they will gather all of those transactions as a group, and what they will on the database. And what they do is they would set up a scheduled time where they would process all of those transactions at once. And we do that as a batch, so that way it's convenient for the operation in the business. Now, when you process it and sync that with different server, you have to make sure that the time is synchronized. Now, if it falls outside of that time gap, what will happen is you will have a mismatch of information. So let's say that I have Bank of America database. It needs to update all the other databases at all the location and all the branches. These system needs to have a way to synchronize the time, and there would only be a small time window where the data would process that is accepted. Okay. Now, in the case where we're in different time zone, let's say somewhere in Japan or somewhere in Europe, what will happen is we would use the universal time zone, but the system cannot be too far off in time. Let's say that it would be a few minutes off. We can set it to be processed because that still works. So that would work the same in a network environment. let's say that you change the rule and add the user to the network, and that user is a new employee. This person can report to their desk to be able to access the system within that instant, because you can push the update and your system has to synchronize. Okay. Do you have any question for me?
Yes, I'm sorry. The interpreter has a question. Our student is unable to see me in a larger view. He's been fine all along until today. I don't know if it's the setting. Am I co-host, or do I need to be co-host or not co-host? Is there something today?
Let me see. I thought I set you all both as co-hosts.
I'm trying to find out if he could see the other interpreter fine, but when we switch to myself, my picture is so small, and he's checked some of the settings and it's not successful.
So hold on one second. Let me stop share real quick. Yeah, I made you co-host. And then I also made her co-host.
He said he wasn't able to pin. The interpreter screen is so small, I cannot pin the video of the interpreter like last time.
Okay, so maybe that's a Zoom push, but let me see if I can pin it. Can you pin?
You should be able to pin me. You can try to.
Okay, yeah, let me see if I can pin you.
I mean, I could leave and come back if I need to. I don't know if that's.
So I'll add it to Spotlight. Is that?
Yes.
Okay.
Maybe will help.
Is that better now?
Yes. Okay. Thank you so much. I think
You're welcome.
I appreciate it.
Yeah. So I think at this point you can also switch, but if I need to pin the other interpreter, I can also do that as well. Okay. So we talked about synchronization on the network. And then one of the protocol that we want to mention is when the server assigns IP address, right? We use dynamic host control protocol. We talked a little bit about this last week. This can be a server system. It is your home router. It has that capability to assign everybody different addresses, different devices, different addresses. Now you want to lease the address, and that was implemented because version 4 doesn't have that many address to work with, especially for a very large network. But also we want to reserve a static address for our network system, like printers, servers. So that will be static, and then the dynamic address that would be used for computer, smartphones, and user systems. So DHCP is in charge of that. Now, this is a role that you install in the server environment. So when you install the operating system, that doesn't have anything ready. So you have to enable or install the role for that specific service. Okay, so that uses port 67 and 68. Now this is often on. We want that to be enabled. So we never really block that unless you have a very small network and you're using all static address, then you would disable the DHCP component, but it's used to dynamically allocate address. So let's say that you have a user that's going to go on vacation for a month, and this person shuts down the system, that their old address can be redistributed to another computer that's used by another user. So we can maximize the address use by using DHCP. Okay, so in your notes, I listed the protocols and the description. We talked about SIP. The ones that I didn't mention in the assignment questions were RTP. This is real-time transport protocol. It's used for voice over IP. Everybody uses now. This is also used to deliver audio and video, and it's a way that we can multicast. So the Zoom component, Zoom also uses this to be able to send it to multiple systems. So that's why you have many participants that are connecting, right? So it's a way that we can distribute voice and video to from one source to many sources, to many destinations, I mean. Okay. It's also used for unicast application, could be one-on-one, right? So instead of a conferencing call, we can do a one-on-one call, like FaceTime. Okay, but you can FaceTime with other people as well. But you can do a unicast where you can send it, you can create a video also and then cast it to another machine. Your MGCP, this is also used for multimedia. This is a way that we can convert data, right, that's required to packets. This is a way that we can distribute some of the multimedia, especially when you're dealing with conferencing. So some of the game engine, some of the web-based media servers is using this. So you do see MGCP, and that's using the higher port number, going into the more uncommon port range in the higher than the 2000. Then simple management for network, we already talked about that. So it does a periodic poll. Okay. All right. Any question? Okay. So now I talked on Secure Shell, which replaces Telnet. And then whenever you're accessing a web page, you're using port 80 or HTTP. Now, if you want to have secure connection to the website, you're using port 443, which is HTTPS. Most companies have transitioned to use port 443, okay, HTTPS, but not everybody actually have that enabled throughout the web. So approximately there's 9 million different websites that are available worldwide and growing. So probably close to 10 million now. So the majority of those websites are secure, but not all, right? And we'll talk about security in the next week. So that's port 443. So in the lab today, you are going to block certain ports, right? Like HTTPS, you can block certain port by its number on Windows Firewall. And so that way, if the user trying to use that port on their system, it will not work. Okay. All right, we talked about network time management. One of the protocol that Microsoft implemented, it's called Lightweight Directory Access Protocol. It's Ldap, and it's TCP 389. This is how you would authenticate to a network using Active Directory. And Active Directory is a server role that would manage users and computers that connect to that network. So let's say that I authenticate to RCCD network to be able to submit, let's say, my timesheets or access some of the resources that are shared by the district, or download something from the network drive. I'm actually a user in the Active Directory, and the server uses that to manage my account. Okay. So Ldap is commonly used in Windows network environment. And your Internet Group Management Protocol, this is, we manage IP multicast sessions this way, so we can have it send to specific group of computers to recognize or obtain the messages for the host and the multicast group. So when you see multicast, meaning one source to multiple destination point. Okay, so this is often used by servers and network systems. That what you would see with IGMP for multicast streams. Okay, using IP addresses. NetBIOS is old. It's used to detect systems in the 80s and 90s. It's still being implemented for Microsoft networks. So there were two companies that implemented this. The first one was Novell. They were the first few that created network operating system. Then Microsoft took the idea and implemented it into their operating system. So this was launched in 1980. It's still being used by network administrator as a backup protocol for, you know, detecting systems that are inside the network. So it allows you to connect the client system to the server. Okay, but we have newer protocol now. So then your SMB. SMB is a way that we would use to share files and printers. And I read too that Zoom also uses SMB. This is how you can drop files into the chat, and then people can access the chat to download the file. So it uses port 137 for UDP, and also TCP, it uses 137. And then on the message block, it also uses 443. So SMB is unique in such that it has many ports that it can utilize. Now you can use any port number if you link that protocol to a number, okay? But by default, these are the port number that's used by the protocol. And then domain name service, we touch on DNS. You saw this in the lab last time, where we would convert like a domain name, FQDN is fully qualified domain name, to an IP address. So the job of the DNS is it needs to be able to have the client connect to a certain domain using the address or the name, host name. Okay. All right. There are many also DNS that exist in the world, and we do have an agency worldwide to manage all of that public IP with the domain name. And some domain names are seen by the public, but the IP addresses might be hidden. Okay. So we talked about DHCP, and it also uses Bootstrap that's in the back, or BootP, which is a little different than DHCP, where it assigns addresses, but for the hardware address, it needs to enter into a table, where DHCP is automated. Okay. Question? Are we okay with the screen? Is it still small?
We were able to fix it. Yeah, and this is the
Okay.
interpreter. I had to manually just click spotlight, and then that changed it back to the size
Yeah,
to see.
yeah, I think it allows you to do multiple spotlight too, where you can, but Zoom changes every other day, so I don't know what other things that they implement. Sorry about that.
Yeah, no problem. I think they must have just changed something because yeah, I was doing it automatically, and something's changed about it upstairs too. So we'll just keep that in mind. Thank you.
Okay. All right. So for next week, I'll push updates on my system and see, because sometimes it also is to the Zoom versions for the host as well. Okay. Any question as far as protocol? So for the quiz, we need to know our protocols. Okay. For certification, we need to know our protocols. And for job, we need to know protocols. So this is our world, acronyms. Okay, so let's talk about routing. I added this portion because I think it's important that you understand how the router works. We're not going to go too in-depth into routing for the sake of time. But if you're interested, you can also take CIS40 and CIS41A. We have a switching and routing class specifically, comparable to some RCC classes. So in number 2, it says, describe how the router forward the packet to the correct destination. Now, the router's job is it needs to get the packet from the source to the destination quickly, okay? And what it has to do is it has to find a path to quickly pass it. So my analogy for this is, let's say that you are at your house and you need to pass a gift to your friend who lives 3 blocks away. Okay. Now we can do is we can pass it to another person that lives in the next house, and that person can pass it to the next house and so forth. Or what we can do is we can find, right, the house diagonally across 3 blocks and pass it over there, and it can quickly get there. So the router job, it needs to look at shortcuts and ways to get your packet from the source to the destination quickly. So a way that it would do is it's going to ask all the neighboring routers that are connected in the wide area network. It's going to say, hey, are you available? How far of a distance are you to the destination? And the other routers would say, hey, I am available. My distance is 120, right? And another router would say, I'm available. My distance is 100. Then what it will do is going to pass it to the router that has the shorter distance, because it needs to get there quicker, right? Using that router. So the router job, its job is to use the neighbor routers, other routers from different networks, to learn how far they are from the destination, to learn the remote networks. What path is it going to take to get to the destination? And it's going to determine, oh, that's going to be the best path, the best route. So I'm going to send it to router B or router E, or whichever router that has the shortest path. Okay. Or the fastest. So sometimes it's short, sometimes it's the best path. So there are 2 ways that it weighed on that. Okay. So to really describe this, how it forwards your packet is it learns the neighbor's router, and it's going to determine which is the best route. Then it's going to send it. Okay. And it maintains that information. It keeps that in the RAM. So in the case where you are visiting that same website again, it will just use that information instead of doing it every time. So the router is very smart. It's much smarter than the switch, the regular managed switch. in that it stores that information. It's going to say, oh, I'll just send it through that path again, unless something changed in that path. Let's say a router that has gone down in that path. What that will do is when it gets to that point, the router that's in charge of that packet, it's going to say, oh, which other way I can send it that will be best. So each router would do this, and this is how we have the faster responses in the internet environment. Okay, so routing is very, very cool. And the more you get into it, the more you're going to understand how our communication system really works. So routing is on page 5. Okay. Now the routers doesn't really interact with the computer. It interact with other network appliances. Its job is just to get the packets there as fast as possible, as best path as possible. Okay. So what does it look at? It looks at the network address, because in an address, there's only a portion of that address that's going to pertain to the network. The rest, it's going to point to the client. Okay. So it's like the post office looking at your zip code first and get it to the city where your house is in. And then the post person would be bringing it to your house. So the post office is like the router. It only cares which network that it needs to get it to, and then the switch job is to get it to your computer. So the neighbor router would provide the information for it to learn, and it will store that in the RAM. And then it would determine based on the calculation of the route, and it would determine which network that it would pass to be the best. And then it needs to verify that, right? Not only that it needs to determine, it needs to verify that and store that information. Any question? So when you're looking at this, okay, you see that the way that we route this, if you're looking at the addresses here, you notice that the third octet for this one is 10. The third octet for this side is 40. The third octet for this is 30. And the third octet for this is 20. This is a class A IP version 4 address. So in class A, these numbers that are separated by the period, they're called octet. And each of these octet represents either network or client. So in class A, the first 3 octet represents network. Okay. So if you see the 10 is different than the 40, then different than 30, then different than 20, these are all separate subnetwork. Okay. They're all separate subnetwork. Why do they do that? Well, they do that to separate system communication and to make sure that they accommodate the number of clients in a certain segment, because there's a limitation on how many systems that will be connected in different part of the network. So I can have it as different branches, right? Or different location. I can have it as different department where we don't really share files. And if we do, we use a router to route the files back and forth. So what the router's job will do is going to say, hey, right, where's the router in this network, this network, this network? So let's say that you have internet traffic coming in and it needs to get to this side. What it'll do is we're going to pass it to this router, and it's going to know exactly what segment that client system is from based on that network address, the 10, 10, 20. It's going to say, oh, that's the zone. I'm going to forward it to that zone. And then the switch job is to get it to the right computer based on MAC addresses. Okay. Any question? Okay, so here's another example. Okay, this is a different class address. So we can have one computer connecting the next computer. Okay. Now, in this one, it's a different class address. So we have network, network, host, host. So in this case, what it simply do is simply you're going to use the switch and be able to identify it. But in the case where if you have, you know, different sub network, it'll just use the router. And some switch is able to route as well. So depending on the layer of that switch. Okay. And then here's another one. So this is a web server. And let's say that I'm sitting at host A. I'm trying to connect to the web server. So it's going to use the router. It's going to get it to that network. And then once it passes through the second router in the destination network, the switch job is to bring it to the web server. Okay, and this is how we create the internet. We connect things together. So the router's job is, the router is the main core, the main bone to the internet structure. Okay, any question? So here it gives you a little bit of the summary on what's happening in that network, how it gets from the host A to the HTTPS server. Now, some companies would use dynamic route. Most companies would use dynamic route. Large corporations would do that. Static route can also be used. It's like this. Let's say that you have a specific way to get to school and you would use it every time to drive to school. You will not alter, you will not take detour. This is a specific way that you get from point A to point B. And that's what static route is. We would say that we would go down this path and that's it. Okay. So why do they use this? Well, they use it for specific security reasons. If I need to only route it through that way, I don't want to pass it to the neighboring network. I wanted to just get it from point A to point B in specific, using specific router. Now, dynamic, some of the system use this to quickly transfer your data from point A to point B. And that can change moment to moment. It can change from day to day, right? It's like how we can take detour to get to the destination, right? We can take the freeway or we can take the inside street to get there. So dynamic, the system will determine based on, right, the adjacent routers, how those are also set up to detect other routers. So the type of system that uses that is autonomous system, and all communication company has them. Okay, that's how when you accessing the internet, it can quickly give you the web pages. In the case where if one router is down, it's able to send it through a different way, take the detour to get to the destination. Okay, so to answer the next question, there are two different types of route. There is dynamic route and static route. Okay. Now, what type of system uses dynamic route? You have static route where each router in the network contains a list of IP to send the packets. It's not good for a large network. Okay. In a very small network, that's perfect. But it causes congestion and as the network grows. So static route is often used for security reasons still, okay? It's kind of like how you know that that road is safe and that's the only road that you're going to take. You will not go on the other street. Okay. Dynamic route is used in a large or very big network. It allows us to automatically add new routes to the table. So that way your packets can be distributed different ways. And autonomous system uses dynamic route. So in a large network environment, they would set up these appliances, could also be router, to take that role, is to autonomously, meaning that it would just automatically, right, and it updates its list of path to get to the destination. Is that what is called in system log? If you look at the router log, you would find it. You won't be able, your system does have some of it. I'll show you how you can look at routing table in a little bit. But you do see some of the path that it takes to get your data from one point to another using command line. Okay, you can look at the MAC table and the IP table. Okay, so some system will have that log, but it's, you know, if you look at the whole network, you would look at the router. Okay, other questions? Okay, so make sure we understand the difference between dynamic and static route. Very cool. When I started learning networking way back, this was one area that I was fascinated with, because the technology that goes into this gives us everything at hand, from internet to access to resource like communication. Now we digitize, so you can call anywhere in the world and all of your data, right, is 0 and 1s and in packets, and that gets distributed across all the route. It sends through the routers and it gets to, you know, it could be Asia, Africa, Europe. Very, very cool. Okay. Any question? Okay. So if you look at the notes, you can find that answer on page 6. Okay. Number 3 is on page 6. Okay, so let's look at some of the specific ones. I am not going to go in depth with too many of them because that becomes a different class. And so I just want you to have a general understanding of how routing protocols work. So just like any network appliance, your router has specific protocol that it uses. Okay. So in routing, we break it up into 2 different types of route, static and dynamic. And under each one, we would have a group of protocols. So in dynamic, you would have IGP, which stands for Internal Gateway Protocol. That's for inside the network, how it gets routed inside the network. EGP, it's used for external gateway protocol that uses outside of your network. So when your packets leaves, right, that router, that's external. Okay, when it gets inside the network, that's internal. Okay, so it separates the category. The inside the network, the IGP is what you would see with a lot of the Cisco appliances and some of the router technology. So it uses a thing called distance vector and link state. So there are different ways that it would determine which way to go and what's best. Okay. So with that, it shows that you would have a protocol called open shortest path first. What's available and the shortest? Okay, Ospf. This has been around for a long time. Cisco uses this too. All routing vendors, the company that make router, also use Ospf. It's a universal one. And then Cisco also have their own protocol that they created for their system. Now, what they're saying is sometimes when you enable certain protocol, that's the higher structure protocol, you have to disable all the child protocol or the sub protocol within to reduce overhead resources, like use of RAM, right? Use of processor. So when you're using a protocol called EIGRP, Enhanced Interior Gateway Routing Protocol, they usually recommend that you disable some of the other protocol to improve about 30% of your network performance. No need to use all the sub protocol when you have that hierarchy, that higher protocol that you're using. Okay, because it would solve the major problem at a higher level, so it doesn't take up your hardware resources, which requires overhead for each protocol. Now, if you're using a router that has more memory, remember that it retains all of the routing information. That gives you a faster performance in a network. Okay, so we can increase it by 50%. That's a lot when you use the major router that has more RAM, that has more storage. Okay. Question. So so before I go into this, let me point you to the section that talks about distance vector. Okay. So for the next question, you can go to page 7, which is question 4. It asks you about distance vector. Okay. So in the protocols, we break it into multiple categories. The first one is called distance vector protocol. It would find the path that is best for the surrounding network based on the distance, and it would have a value. So when you set up the router, you would set up and you would say that, this to the adjacent my neighbor router is this value. And it uses that value to determine if this is the best. Okay. So, and then on top of that, it's going to say, okay, how many routers do I need to pass through to get it to the destination? Let's say that you have to go to school. If you only pass through 3 streets that are generally short, that will be your best path to get to school. Versus if you have to cross 10 streets, that is generally short. Okay, so it's gonna based on the number of routers that it needs to pass through. That's how it's gonna choose distance vector. The next part is link state. And this is what we call the shortest path first. Okay, so it's going to determine based on the shortest path that it would use based on maintaining a list in a table. So it would say, oh, this is the record of the path. Is it the shortest? If it is, it's going to use that one. So in the link state, it maintained the state of the neighboring routers and the topology of the network internally to determine how it gets there the shortest way. Okay, so the true difference between these two is that one has 3 tables that it uses, which contain more information. That's why you have to use more RAM. The other one, it still have to have a table, but it does a calculation based on the value. Yeah, so infrastructure can pertain to the larger, right, incorporated everything inside the network. Could be utility, it could be, you know, appliances and systems and software and everything. So infrastructure. Any question about routing protocols? So when you take Cisco certification or other certifications that relate to routing, right? So Network Plus does ask you a little bit about this. Cisco would address this more because that's really their technology, is to switch and route. Okay. Question. So as we talked about in the previous page, when you configure a router, right, which protocol should be used to improve network throughput? What type of core routers should be used to increase network response time? So we should use EGIRP and disable all the other ones. Now, if you're using older router, you might not have this. You would only have, some router would have specific protocol use only. Those were the old router. Now on the new one, you would see that it has different capability. So when you shop for a router, your home router is a little different because it's simpler. But on the network scale, you should look at the protocol that's come with that router, and you can tell whether it's going to be suitable for your network. You can utilize this protocol for your network, how efficient that would be. Okay, that's on just like more a summarized perspective. There's a lot of other things that we factor in as well. So we can improve throughput by 30% if we disable some of the back-end protocol and use EGIRP. We would also use router with more memory to dynamically route our traffic. I love teaching switching and routing because that's really, it's like how if you want to learn about software, you should learn to program it. It's like that. It's the core of it is if you understand that part, you understand, you know, the majority of the network. When will the class be offered? We're probably gonna look, maybe I might offer it in the summer, if not next fall. We started launching a lot of the certificate now, so, and we got employers looking for students to start apprenticeship. So if you haven't signed up for apprenticeship, you should do that. Okay. And we register our apprenticeship on apprenticeship.gov. It should be up on the website in 2 weeks. Yep, no problem. Question? Okay. So you will find this on page 6 and 7 of our notes. Let's touch on troubleshooting now. Okay, so routing. One of the ones I didn't mention was the hybrid, which is a mix of both. And when you get that router, it would also say, you know, this is a hybrid router. It uses distance vector and link state. But you would see BGP under that type of router. Okay, and that's the type of protocol that it uses for using both. Okay, so you see a lot of the more current router would have both, so you can choose either way. Okay, I added this so you can see the difference between the old protocol for version 4 address, which a lot of people still use, and then the new protocols. So in the version IP address version 4, they uses RIP, but RIP NG is used for version 6. Okay, which is an upgraded from RIP version 2. So RIP stands for Routing Information Protocol. It was all routers have that capability. Okay, so this is what they upgraded for version 6. And it allows loop avoidance, so that way, you know, you don't have things that just keep looping using port 521. And then for the EIGRP, there's a V6, the version 6. And it does neighbor discovery also. And it uses the reliable transport protocol. So it's faster than the old version. Open shortest path first, version 3. That's for IPv6. And it would have updates with addresses. So your version 6 address would look something like this. Network addresses. Okay. So that just a little more detail for you. All right. So troubleshooting network is a constant. It's one of those that you know, this is why the job is always there for us, right? Small scale, large scale. You know that people need troubleshooting with the system, but now when you have connected system, there's more issue. Okay. So the textbook, it talks about super simple stuff, triple S. Okay. Some of the things that you just have to look at, like power cable, that's simple. Okay. Did you type in your password correctly? Because you're going to get calls that I got locked out of the network. I typed in my password 5 times and it was incorrect, right? Can you please help me? Or I'm not able to print because I'm, you know, every time I click print, it gives me this error. I don't know why. I think you have a problem on your network. That's what they would call for, right? So you want to focus on the simple stuff first, and then you want to troubleshoot from there, right? If we can fix the simple stuff, then that's done. If not, then we would look at other theory for our solution. So, okay, this makes our job in demand. So for number 6, it asks, when troubleshooting a network, what super simple stuff should you check? Check verify login procedures and rights, right? Typo is a common issue. They type their password wrong. They use cap locks. Okay. And then also, sometime there had been configuration that changes what they can and cannot access. So for example, this person was in a different department yesterday and this person can download files from the network drive. Then this person moved to a different department the next day. The rights has changed. They don't have access to certain system anymore, right? And that can create problem because they're so used to doing certain things and now that's changed. Okay. So a lot of the times you're going to have to reset password. That's very common. Now we have automated tool for that. However, right, in a small network, you will get tickets that would ask, can you please reset my password? I'm locked out of my system. Okay. And then we want to check what are they given the privileges to do. The system rights is like shutting down, right, running application, installing software, stuff like that would be rights. Permission pertains to files and objects, such as, you know, editing a file, okay? Creating a new file, that's really permission. Then you also look for lights and collision lights. So collision lights are amber. Link lights are green, and you see this on your home router, right? If it's working, it's going to blink green. If it's not working, it's just going to be all amber, meaning that you're not connected. There's collision. So when we send packets simultaneously, sometime two systems can send it on that same path, and that creates collision. Also check power switches, okay? Cords, adapter. It could be that the switch they're using is off. Somebody touch it and disable, turn it off. So that will be part of the SSS. Look for user error. Like I said, did you have cap lock on? Right? You would ask them, can you walk me through how you log in? Can you type your password slower? Okay, and that requires a lot of patience. So this is the type of work that you look to do. Okay, so those are some of the things that you should check when you're doing super simple stuff. And then if it's beyond this scope, we have to look at other areas, right? Like network configuration, server configuration, IP addresses release, things like that. Any question? Okay, so for 7, it asks you, Pedro cannot log into the network. As a support technician, how do you troubleshoot the problem to help Pedro log in the network? Because they're not going to tell you, Pedro will not tell you why he's not logging into the network. That's your job, right? So Pedro will call and said, I cannot log into the network, right? Every time I put in my username and password, it says I cannot log in. Okay, so just like our last list, we want to verify login procedure. Check for bad typing. That's super common. 99% of the time, it's usually that. And it could be that they're using the wrong password, something that they remembered from last week and they changed it. Or sometimes they forgot their password. I forget my password when I pay bills all the time. I just reset it, right? But imagine if I have to call in every time I forgot my password, right? So now we have an automated process where you can click a button, which is the link. When you reset it, it saves your new password and so forth. Okay. Then we want to check Pedro privileges, maybe, right, he's a temporary worker and he's not going to be allowed on that network after a certain point. Or sometimes people get fired and they're still trying to log into the network. So the procedure for, people being fired, most of you know this, not that the person clean up their desk and leave with COVID-19, you just disable their network account. Okay, right away. Because 80% of the user will take existing work content to leverage their next job. So we have to, your job as, administrator and technician, you have to disable the account immediately. Okay. All right. Second thing we need to check, if all of that is verified, right? Correct password, correct typing, and the privilege is allowed, then we would check connection. Network interface, card, or wireless adapter. Is that working? Right? The NIC would have also a linking light. So see if it's on. Also, a common issue would be cable. Okay, bad cable. That tends, because people unplug and plug in their cable. So sometimes that can cause problem. So if we can physically secure that, you can zip tie everything so tight that they can't unplug it. Okay. We would look at network system power. It could be that there's some outage in power and that could take out a certain part of the network. And then we can also test signal, especially on Wi-Fi. You have to take a look at the channel and the signal. Okay, frequency, channel, and signal. And then on the Wi-Fi end, you have to also look at, security, encryption, which, if they're using the proper keys, if there is filtering block on their system or that user account. Okay, very simple. Now, likely you would see a lot of the times it's the user is faulty, meaning that that person forgot password or something happened, right? They clicked the wrong thing maybe. But other times you would see that will be hardware problems. So some of the things that we need to troubleshoot with hardware is, number one, we can change the hardware settings. We can disable, enable certain port. We can also configure that to allow, disallow things on the security end. We can also update device driver. That's very important for network appliances and system, including printer. Okay. So sometimes it requires that we update the driver for the device, like network interface card. And lastly, we would replace the dead hardware. So if our hub is dead, then we would take that out, replace it. And end of life is about what, 5 years for a lot of the smaller appliances, 3 to 5 years. Okay, any question? Okay, so let's look at a scenario, see if you know how to solve this. It says a user in a network cannot access the network drive or printers. How can you determine if the problem is rooted at the single system or in the network segment? How do you troubleshoot the problem? A lot of time, the user is going to think that it's a network problem. Okay. So when the call comes in or when that ticket comes in email, it's going to say, you know, something's wrong with your network. I cannot access the network drive or the printers. I can't print anything. I cannot download anything from my department drive. Now we have to really isolate the problem at this point. We have to look at, is it the computer that they're at or is it the network that they're in? Okay, two separate areas. So, and this can happen at home too, right? You're using your tablet, you're trying to watch a movie on it, or your kid's trying to do that, then nothing is played, right? Then what do? Do you restart the tablet or do you go and check your wireless router, right? So that's like two separate issues, right? Is it the router or is it the system? Okay. So in your notes, it talks about how you can isolate this. So first, we need to test connectivity from that system, right? So if you have the problem with the tablet at home, restart the tablet, see if it's gonna get Wi-Fi signal. So you need to test that communication first, okay? Another way that we can see if it's a network problem is to use another system in the network, an adjacent system, let's say, at the next desk. Ask that neighbor user to access that drive for the printer. Does that work for them? If it does, then it means it's a system. So you can narrow it down that way. So if you have a tablet and a smartphone at home and the tablet's not working, but the phone is working, then it's the tablet. Okay. So we would test the connection of the network drive and the printer from another system. If the network drive and the printers are accessible using another system, then we would know that the original system has issue. Then you would look for cabling faults because it could be that they disconnected the cable or the cable is bad. It could be that there's a bad network interface card, power issues, misconfiguration, or the user. Okay. And there's a joke in IT that it's always the user. So, and I sometimes is like that too. I get frantic and I said, yeah, so that worked. I would say that, you know, there gotta be something wrong with the system, right? But it's really me. I didn't do the right thing because I'm rushing. Okay. So here I put the test network drive printer using another computer, like what Sarah mentioned. Ask the other person to print and access the network. If that works for them, then it's that system. If the network drive and printers is accessible on another system, then you can check for cabling, NIC, power issues, and OS misconfiguration on the problematic computer. If the network drives and printer are inaccessible using another system, then there might be server misconfiguration, network device connectivity issue, permission and privilege control in the server might be misconfigured, right? I might have, a new administrator comes in and this person might have disabled or removed that user from that network drive, okay? Or sometime if they violate policy, our security appliance would also kick them out too. If you set the rule, that will do it. Okay. Question. Okay, so another issue that you come across would be network address conflict. So when people trying to put in manual IP address or the static address, sometimes there's a typo or they would put in the wrong address. When two systems have the same IP address, it generates a conflict, which can take down the whole section of the network, right? All IP address, each system needs to have a unique address, okay? So if you have network IP address conflict, it will cause network disconnection for that system and the other system that has the same address, or sometime that whole section, that whole row, or that whole room. So you might have disconnection of multiple systems or the segment. So this is why after you check the hardware, the user and the hardware, you would check the network configuration. And when you call tech support, they would have you look at IP configuration, right? IP config, or on Apple system, it will be if config. I think they use a new command now. Linux uses if config. Okay. Any question with number 10? Let me bring this down so in case you're still typing it. Okay. So let's talk about some of the issues, and this might help you. Okay. It will be the same with Linux and Apple. So one of the things that you want to do is to reproduce the problem. That's going to help you really pinpoint where things go wrong, right? Have the user walk you through every single step, right? Like show me how you access the network drive. Show me how you log in, right? Can you go through the steps slower? And so that way you can determine the source of the problem. Sometimes it cannot be reproduced. So you have to really narrow down so you can come up with a theory what could possibly went wrong. Okay, so just to point that out. All right, so I talk about the simple stuff. All of these talk about how you can check for various things. Okay. And when you restart the system, a lot of the times it renew IP addresses on the router, right? It still need to communicate with the wide area network, which is the service provider. So with that, you know, it would also refresh and also update if you reconfigured it. So definitely good to restart, and so that way it can reinitiate the services. Okay. So we already talked about isolating between the workstation and the network. All right. So let's talk about some of the areas in networking that we often see when you manage a network. Okay. Especially with cabling. So one of the things that you often come across that will be an issue is, excuse me, crosstalk. So when you have wires that are together, like, you know, when you did your part 1 project, I was looking at some of the pictures you sent me, right? There's some of you that have a lot of wires together, and then there's some of you that, you know, you run your wire and then you would use a tack to tie it to the wall. So try to avoid a lot of the adjacent wires because that can create crosstalk, right? And that degrade your signal, especially if you have a lot of them together. Now, in the data closet or in our server room, sometimes we don't have that choice. We have to have everything connected back together. So what you can do is you can use twisted pair and tighten the twist. So the tighter the twist, the less crosstalk that you're gonna get. So this is why category 6 cable is better than the 5E or the Cat5. Okay, that's why a lot of the network administrator, they want to upgrade to a better type of cable that has tighter twists, copper twists, so that way you have less slack in the copper where you don't lose signal. So crosstalk happens when you have signal bleed when the wires are adjacent to each other. Okay, so I have some question in the chat, but let me bring this up. So it asks you, how do you reduce crosstalk in the network? You would do that by using twisted wire and put them at 90 degrees angle, or using the newer category. Okay, so Cat6 is good. It's a better grade cable. It doesn't mean that it would stop it completely, but you would reduce it quite a bit. Or what you can do is you can twist it tighter together, and that will give you less bleed in the signal. But not so tight where it breaks though, right?
Professor, what would give away the fact that you have signal bleed in the first place?
So you would see degradation. So sometime you would, like let's say that when you test your bandwidth, it's always low. Even like when you test, you should use network interface card, like a cable, a physical connection to test. If you test and it's a lot lower than expected, you have a bleed. Okay. And sometimes it's just, made in China, poor cable, and because the way that they wrap it, sometimes they make it fast, so sometimes it's not as tightly twisted. And you often see that with some of the older category. And if you look at telephone cable, it's less twist, so you see that there's a lot sometimes that when you run a long cable or you have it adjacent with a lot of cable, you have a lot of crosstalk. So if you can upgrade it to Cat6, or if you cannot, you can reconstruct that cable and making sure that it's twisted tightly. So yeah, definitely test. For you guys, you can test your signal. In network monitoring tools will tell us the bandwidth, right, from each system and how it's performing. Because even on your, let me show you real quick. If you go to Task Manager, and then if you click more details, right? So here's my Windows Task Manager. It tells me all the things that are running and the type of services and so forth, right? There's a performance tab. It tells me all of the details about my connection, and it's to the bit size or the byte size. Okay. So outside of just testing it using a website, if you go to your, like I'm on my Wi-Fi, but you would have like your interface here, I would see how my pattern would be. And I'm strictly on Wi-Fi right now. But if you connect, you would be able to see how you're transferring. And, there's factor like the time of the day and such. But if you see like severe drop, then it's a lot slower. So if it's not on your side of the network, it's on their cable on their side of the network. So you have to call for service at that point. Because underground, there's also deterioration for cable too. And they bury a lot of the copper, so. All right, let's talk about attenuation and latency. So two different things. Attenuation is the loss of signal or degrading signal or degradation in signal. So especially with Wi-Fi, right? If you are far away from the source, you would have less signal. We know that. Cell tower, same thing. So what does communication company? They put up the fake palm tree tower, right? They do it a little bit more discreet now because it's a physical security. So at home, many of you are using repeaters or amplifier, but the best thing that we know is pure fiber. Okay, fiber doesn't, because it uses glass core and it uses light, it doesn't lose signal in the long distance. With copper cable, like Ethernet cable, you only have 100 meter as limitation. So when you go from one point to the next point that's 100 meter away, you definitely have degrading signal. So attenuation is caused by being far in distance. So we can use repeater, right? We can use amplifier, or we can use pure fiber. And I'm not talking about coax hybrid, right? If we use fiber to fiber, it's definitely not gonna have degrading signals. So where you start and where you finish, it's still the same. Okay, but you do have limitation with distance, but further. Then latency is a delay of signal. Okay, so it's just slower. Okay, so you would have latency, and some of this comes from the security side, right? Too many rules that's applied. So we don't have much response because it's filtering everything. So when you start becoming worried and you filter too much, that can cause a problem. It slows down everything on your network. But if you don't filter anything, you create problem too. You open up, the possibility that somebody can enter your network and create problems for you. So the things that we can use to help latency is to use load balancer, where we can keep it pretty stable in a range. Okay, so during the peak time, we can load balance it. We can redistribute some of the traffic to different areas of the network, so that way it's not going to clump up in one area. And so the traffic can flow smoothly. It's kind of like how when they have construction on the freeway, if they're going to close one lane, possibly we would be able to open another lane on the other side just to let the people by for that section, right? Or open the carpool lane for everyone to go in. So that way you don't create congestion at that one point. So we want to load balance it. Question. Okay, and then next we'll talk about jitters. Okay, so crosstalk is on page 12. They have the near end and the far end crosstalk. Attenuation is far away from the source where you have signal loss. Latency is the delay of signal. Slow, right? You want to have low latency, not high latency in a network. Jitter is where you have inconsistent in data flow. And this is what happens when you have Zoom drop at home. Okay. And then sometime, like if you notice, like in certain part of the day when not too many people are on, you have increase in signal, right? But this jitter will be inconsistent. You have data flow that's fast, super fast, and then it drops to really, really low. And a lot of the times it's caused by congestion, time drifting, or route changes. Okay. And that can come on service provider end too, not just your own network. And so when you're dealing with like, you know, call center where people call in and they would file complaint or for customer service, or in the case where we're doing web conferencing all the time, then you're going to see a lot of problems. You're going to get a lot of user drop off video conferencing. Okay. So with that, we can answer with jitter. Okay. What we can do is we can reduce large file transfer. So a way that we can do this is we can teach the user how to use data compression to make the file into smaller compressed file. We can also, instead of transferring, we can have a repository of file to share with the rest of the network, and we will just upload it once and everybody can see it on there, right? Like cloud-based. We can reduce large packet queues and routers, so we can control the policy where people don't download a movie at work or audio files, stuff like that. So we can reduce traffic queues that way. So you can block some of that traffic using firewall. You can screen some of that traffic using monitoring tools. Now, another problem that we would have is collision. So when you have two systems that's sending at the same time on that same path, it's going to collide. So in the olden days, we would use the carrier sense multi-axis collision detection, CIS824B, and that was built in with some of the appliance. Now, what we can do is we can create virtual circuits, okay? Or we can even set up virtual area network to set it up to subdivide your network into portions. Physically, they're not, but virtually they are, right? To control your traffic. So you can reduce collision. Okay. And a lot of the times our network appliances like switch and router has this capability for configuration. Any question? So if you plan to work for Spectrum Frontier Communication Company, you have to know all of this stuff, right? They have certification within their own company for installer and manager and, even support. Two of my former students, they work for Spectrum. They started as installer and now they're at the data center for Spectrum.
Night crawlers.
Okay, question? Okay, so the next question asks you, and we'll finish a little bit after 2, but I'm trying to wrap up some of the questions now. ABC Corp uses 2 wireless access point AP for employee wireless connection in the network. During regular operation, there are more than 120 users connecting to each access point. That should not have the S, sorry. The user complains that the network bandwidth is low and the download is very slow. What is the cause of the problem? How do you improve the network bandwidth? So it's just congested, right? Like you only have 2 access points. There's approximately more than 240 users simultaneously using both of the access point. So that means that there are too many wireless devices connecting to each AP, when you reach about 120, 125, it's going to get a little slow, okay? Which result in what's called bandwidth saturation. And could be that they're watching movies, they're downloading, could be a lot of different things that they're using. So to improve the network bandwidth, you also need to consider improving the back end of the network, like fiber and, fiber core connection to your main network. But what you can do is you can redistribute the traffic by adding more access point, maybe 2 more. So you wanted to get it under 100 per access point to minimize the congestion. So you can redistribute the wireless connection. And if it was me, I would also block and filter. What will happen is, sometimes you have public network and too many people are on it at once. So what you can do is you can put in time window where, like Starbucks, they do that, or at Panera, I noticed that they do that. I don't connect to their network, but I've seen people connecting. And so you can have them on for an hour and then they have to get off, right? Or you can have it renew with different keys, so that way not everybody on it at once. So you can control it in many ways. But this is a problem with bandwidth saturation, that it's just too low to support everybody at once. So you can install additional access point, and also you need to upgrade the back of the network. Okay. I'm going to go over one more and then we're going to take a break. I'll finish the last few, talk about the lab, and then we'll call it a day. Okay. All right. So let's talk about signal bounce. And we touched on this when we talked about wireless last week. We talked about antenna last week. So often when you're dealing with radio frequency, that could come from hand scanner to Bluetooth to microwave to, right, your wireless router. So some area of this is that sometimes you would have reflection, refraction, and bounce. So in your notes, after collision, it talks about shorts, mismatch, interference, and then it goes to inference. So interference, we talked about it last week, when you have too many of the similar devices on the same band, that creates problem. Here's saturation of bandwidth, incorrect encryption frequency and such. Bounce is on page 13. So you can install repeaters and reflectors to bounce the signal or to boost it to cover a span of area. Because what will happen is that the signal uses multipath, and it would reflect off objects like water and glass wall, that it would arrive in a very low. So for the people that has glass wall in their building, right, the companies that have glass building and glass section part of the building, they have to constantly use amplifier and repeaters to keep that signal consistent throughout the company. Now, going back to last week's question, right? I think someone asked me about how can you make sure that people don't see your signal? Easy, right? Use something to reflect it, okay? So for the people that lives around water, like lake around their house, you would see that a lot of the time the signal would reflect it off and it would become degrading after that point. So this is why company would put you know, glass, not just to seal out noise, but also sealing out signal too. So what you have is with bounce, you can have the strongest signal to be controlled using antenna, like directional antenna. And then we can phase out some of the signal by using reflective materials. Okay. And some material absorb signal, some material reflect signal. So, you know, dense wall would absorb your signal, and then glass would reflect your signal. So use the strongest signal antenna to direct that signal in certain area of your network. And then we can use other material to phase out the signal in some section. And this is how you can control it physically. Okay. Any question? All right, so let's take 15-minute break. Get a chance to get a snack or something, water. And then we'll come back at about 2:15, 2:16. We'll pick back up for the last few and talk about the lab, and then we'll call it a day. Okay? All right, let's take a break, everybody. Okay.
I have a quick question, Professor.
Yeah.
Do you possibly still have room in your next class, the security? I'm interested in getting in if it's possible.
Yeah. So email me. I will give you the access code or authorization code.
Sounds good. Thank you.
You're welcome. Okay, Sarah, I will address your question at the end. Would that be okay? All right. So let's pick back up. Okay, so we left off with 15. We talk about signal bounds for wireless. So you want to use a single antenna, and that would give you a direction on which direction you want to send the signal. And then you can disable the other antenna, or you can use a material to face out the signal in the other direction. So that way you don't have the bounce. Now, with signal bounds, you also have multipath, which is what happens is that signal gets divided into different area. Sometime that would cancel your signal, or it would cause data corruption. So your signal strength get degraded over time when it gets separated. So what happens is you can also use amplifier and access point to be able to control how your signal is transmitted. Wireless is a continual maintenance because over time you have wear and tear, especially outdoor. So you want to make sure. This is why communication companies, they put up towers and antennas to get the signal to certain area that so that way it can be transmitted and maintain that signal strength. So some of the things that we see with refraction is that when, like I mentioned, not that you only have reflection, you also have refraction. And in the notes, it talks about both of these under environment. So reflection is when it hits a smooth object and it's able to reflect off that signal. And as it reflects off that signal, sometime that can get dispersed. Okay. And we see this, especially if you're using it for wide area network across different part of your network beyond your router. So as it radiates, it broadens and disperses. So what we can do is we can look at the reflection points, especially in the area of glass or water or any smooth surface that can reflect the signal. You can implement appliances that would either take that signal and retransmit it, which is what we see with access point and repeater or amplifier. We can also use position to really angle our access point or station our access point a certain way where it would cause less reflection. Now, a lot of the things we can't control is environment in the areas that would have a lot of rainfall, waterways, stuff like that. Then we would have to manually install physical things that would control that signal. So keep in mind that you would have some of the environmental impact and also how you position and do your site survey, right? When you install these wireless or radio frequency based appliance would help. With refraction, it caused the direction of the wave to change. So instead of going directly straight down this way, it can angle and send it to a different path. So, and that is often with environment conditions. Also, you have to pay close attention to the system, wireless system, it's when it's outdoor. Especially when you have industrial-based communication, where you have to have these systems. Like for farming, that's common now that they would use wireless technology to detect animal, like let's say that they do free roaming ranges for cows and chickens. We see wireless being used for that in manufacturing, in a campus or a company that have large location. You have to install these devices. And with that, we can't control rainfall, we cannot control waterways, but what we can control is where we position that technology and how that can distribute proper signal for the network. You'd be surprised that a lot of the farms transition to technical implementation, so that way they can streamline a lot of the inventory and the production process. So we see a lot of use in that, and this is the area that you have to look at when you're managing that type of network. And then I mentioned earlier that there's absorption. There's certain material that absorb our signal. And so in that you have some signal loss. So positioning your access point and your, handheld devices and such would be very important. If we rely on satellite system, that's also impacted by the environment. If you have satellite TV, you notice that they still have to rely on some ground wiring just to get signal to come through in the case where if you have cloudy days, if you have trees near your home, you're still gonna get some signal. Now, if you use strictly satellite, a lot of the times that's really depending on how your location is seeing that satellite. In remote location, many people, they have to use satellite communication, which is line to sight. And on a cloudy day, your transfer rate just drops severely. We implemented satellite communication for our bus at Moreno Valley College, the Mobile iMake Innovation Center. It used to be the STEM bus. And for the longest, when I first got on it, trying to help fix some of the problem with their connection with pure satellite, there was, just to download a file, it takes a long time. So what they're using now is they implemented the hotspot, which uses cellular-based technology with the local communication like Verizon or AT&T and such. So that gives us better throughput. So when the students, when they get on the bus, right, we can run VR, we can connect to the internet, we can do a lot of different things. And when they got my feedback on that, we paid approximately $7,000 a year just to get that satellite service, and it's rarely ever used. So I said, why not just look at hotspot technology and use that instead? So we can go completely wireless, we can be mobile, and we can have stable signal. So, and with the satellite, it's installed on top of the roof of the bus, but still, it was still having challenges, because if you park it next to a tall building, right, the building reflects the signal off, and then there you go, you don't have signal at all. You can't park it next to a large tree or any large object. And for the bus, when we take that to school, we have to park it near a building. So it becomes a challenge. You do see a lot of mobile technology like that now, where companies would use 18-wheeler to have network system that go from one location to another as backup. And so we have to think about how we network these systems, and engineers and technicians, they work on these mobile locations. They call it, you know, kind of like the warm, hot backup sites where you have everything you need, but just on wheels. So in the case where we have like some of the previous storm, right, that you've seen in Texas and also prior in New York, they dispatch these sites to make sure that, you know, the people have communication, there's data that support the companies in that area, because you lose landline and that's it. So with that, they have solar panels, satellite system, also cellular based technology, a full rack with server and all of the things that you can think of in a large scale network. So, and you can also run diesel backup power with that too. So it's definitely convenient. Okay, so the steps, like in the previous class, we have the 7 steps. If you study for Network Plus, you need to know these steps. I put down some of the things you need to watch out for in, you know, establishing the theory. There are a lot of different areas that we can troubleshoot network systems. Some of it we talked about. You can also have a rogue DHCP, right? Somebody put up a DHCP server and somehow it connects to your network and it gives out like the wrong IP addresses. That can create a problem too.
Question?
Yeah.
So the 40A class prepares you for the Net Plus exam?
Yes. And I use this textbook for that class. I took portion of the textbook and I use it for this course, kind of give you an overview. It doesn't have all the chapters, but it has the major core to get you the basic knowledge for networking in this class. But in the other class, we will go more in depth with like, you know, like some of the Cisco stuff too, but we would go in depth with addresses, we would go in depth with routing, switching, and some of the other technology. Yeah.
Sorry, is that class being offered in the spring?
We didn't add that course in the spring only because I wanted to teach that class where you can use the rack that we have in Parkside 16, where you would have more hands-on setting up server, routers, switches, security appliances, and get little small networks installed or configured. Virtually, we can do only so much, and it's not what some of the, you know, it's not going to fit for a lot the major population. So I held off on that class to see if we can transition it when we can actually have more access to the physical system. But I'm teaching CIS824B, which is the risk analysis class. It has ethical hacking component. It has, you know, risk management component. I teach it at like bachelor upper division level, because when you do this in the field, you can't do it at the elementary level. So all the other security classes kind of cover the basic. The 41A is like the top, which is it encompasses all the major risk component, looking at threats, vulnerabilities, and how to manage that in every scale. So that's my schedule. Is I teach some programming and then I teach a couple security classes. I'm doing CIS27 Security Plus online only, recorded videos, and then I'm teaching CIS41A, which is part of the security specialist and analyst certificate. Because some of the students, they're on track for that, so they're like 1 or 2 classes from being done with the certificate now. So, but 40A, just to come back to your question, it will be offered as soon as, you know, kind of, I wanted to use, if not summer or the next fall.
Oh, you can teach that class during the summer?
We can offer it during the summer, but it will be intense for the 6 week. I prefer to do it in a regular session. So
Okay.
yeah, but if they want me to offer it during the summer, I might, and that will just be hybrid or online. Okay, so those are some of the steps on troubleshooting. We covered this in the last class. If you don't know what they are, right? These are the 7 listed standard troubleshooting steps in the industry. That's what we use. So you go from 1 through 7, and lastly, you're gonna document. So you, in case you come across the same problem or similar, you have the solution. Okay. In your lab, I'm going to try to wrap this up now for the last part. In your lab, it talks about troubleshooting commands last time. We talked about ipconfig when I explained your lab, netstat to give you statistic and the port connected, trace route, right? Trace RT is trace route. And you can simply do, it's fun, right? You can CMD, I can't type today. So here's my command line. I can do trace RT www dot. If I want Google, I can type in the URL, or you can even do an IP address, a public IP address, right? So you can do youtube.com. And then now with Windows, it's only showing the maximum about 15 hops. You would have more than 30 hops, meaning that it crosses over more than 30 routers to get your traffic to where it needs to be. Now, when you trace it, of course, it's slower. Okay. So we talked about trace route last time. Another way that you can do this is you can do a path ping. So anytime that you don't know, I'm going to close this because I don't have the time to wait for it. So anytime that you want some additional details about certain command, like for example, path ping, you can do a slash and a question mark for the help feature on command prompt. So with this, I can use, this is what call a switch with it, options actually with the options. So you can have it path ping for a certain period of time in milliseconds. So you can add the options to it. In Linux, it's a little different, but we can ping that path. We can use an address, or we can use, a certain host. Okay. So in your notes, it talks about how you can look at network latencies and network loss at the immediate hop. So earlier we had questions like, how do I know if my signal is degraded? You can do a path ping inside your network and see, because what it's going to do is going to give you the milliseconds that it's tracking at every hop, like from your network into the next network into the next network. So it's going to give, I'm not going to do the path ping, but you can also use path ping with like a website, www.youtube, because it's going to take a long time to queue all the details. Okay, so it gives you the statistic of the network mainly. So that's a good one to use. It's been around since DOS days. So ping, we talked about ping, where you can check to see if that system is going to respond, if it's connected. You can directly telnet in command prompt. So when you issue the telnet, it's going to bring you into it's going to launch the telnet exe on Windows. And telnet also works in Linux system as well, right? If you don't have it installed, you have to install it, but most OS releases has telnet. FTP is the same way. You can use FTP command, but you have to use the option with it. Otherwise, you don't see anything as output. You can also use route to view and configure table. So I can simply do route like this. And what it tells me is, if I wanted to show my routing table from my system, right? Like how it routes my traffic. I can do a route print like this. Okay, so let me clear this so you can see route print. Okay, and if you're not sure, you just do a /?. That gives you the help options. But if we do route print, what we have is we have information on the active route from my system to, you know, my router and then to the rest. Okay, so it gives me my version 6 and version 4 table, because, you know, most network uses both, and it also detect all my, you know, the devices is on my band. And to clear is CLS, so that will clear. It drops everything. I try not to keep stuff because I post video online, and I don't, because it's public, and you know, there's certain security measure that we have to take. So sorry if I clear my screen quickly, only because I don't want people to see some of my addresses and stuff like that, where it creates home security issues. I do use a lot of detection stuff, but you know, detection is only responsive to, it's only work best if you have the proper measure and practice. Okay, so for 16, we want to talk about multipath, mean it's signal strength degradation. And that is a, you know, your basically your signal is being canceled, or it could cause data corruption, meaning that it's not going to get back to its entirety. And the for indoor, you want to watch out for glass and water, especially when companies install like a fountain, a very large fountain in the middle of the floor, or those water wall, right? The fountain wall, glass wall. So that would cause refraction, where it would change the angle of the signal. And then lastly, number 18 is what should you do if you cannot confirm the theory to determine the cause of the network issue? So if you came up with an idea that that's the problem, that's the cause of the problem, and if it doesn't work, you need to escalate the problem, right? You need to bring it up to the next level, looking at servers possibly, or even move it to a different department, because you might it be out of your job scope. And then you would come up with a new theory to address the problem. Okay, so that will be the last two questions. But I want to touch a little bit more on the commands so you can see, and all of this you can find at the end of our notes document. So I give you some of the list of the command here, right? You've seen ARP in your lab, and ARP-A is often used. So you can add, you can remove, you can also see. Nslookup is a way that we can find our DNS information. And at home, you're using everything by default for the router. Your router is the DNS, it can be. You can have this is an old protocol, right? This is for the NetBT, been around for a long time. It's allowing you to see your protocol statistic, okay? Especially with TCP IP. So let me see. And when you type that in, it's going to want the option. So you can look at the adapter status, the capital A or the lowercase a, and you have to, so basically you have to point to a remote machine's name. So this will allow us to see remote system. As you see with a lot of the network administration job, you can administer the network at home for most part, right? Once you set everything up, you can remote into your servers and configure, and you can also control a lot of your appliances. And then there will be time that you have to go to the location. For example, if I have a crash, I cannot just reboot the system. If I have power outages, I have to physically drive there, turn on the system, get it start going. So once it's connected, you can remotely manage some of that. So NBT stat allows us to see the statistic, the session, the information of the remote system, but you have to know its name or its address location. So importantly, you can use IP addresses or you can use machine name. Okay, so if it's like a server name, so with the proper ARP setup and DNS setup, you can actually access the domain and the server with the name, or even use NetBIOS. Okay, so that's to show you what else. Sorry, let me get my laptop plugged in just in case. And then for your NetSH, this allows you to reset, and this was used for the older system. Some of the commands still worked, but I want to show you get MAC. So instead of using ipconfig all, which gives you a lot of information, you can use get MAC. This gives us the MAC table, not just our system, but the system that is connected to it. Okay, so it gives us the MAC table of who we're connecting to. Okay, so that is, if you want to look at switches and switch connection, get MAC is a good command to use. Yes, all your grades are posted from the previous class. It's for these classes, it's pass or no pass. So if you completed everything, it's, you know, if you get higher than a C, it's a pass. If you get lower than a C, it's a no pass. So it should show on your web advisor. I have to send the list to IT, and they confirm it that they put it in for the last class. So you can check that on web advisor. Okay, so that is just some of the general lists, and you can find more on commands and practice commands, because when you access server, for most part, everything is in command line. Most servers don't have graphical user interface that you can click, especially web server. Okay, so in many cases, like Windows Server, it has the GUI, but a lot of the Linux server, it just use command line. Any question as far as the assignment? If you have this, submit it if you completed it. If not, make sure that you get it submitted to me by Monday. Okay, I know it's open till Tuesday, but don't wait till the last minute, because if you can't connect, then you can't submit. So try to get it to me before Tuesday. I have to finish your grade by Wednesday, and they check on Thursday. So, all right.
Quick question. What was 19 and 20?
Oh, hold on. Here's 19 and 20. So why should you document the problem? You're welcome. Why should you document the problem you're finding? So that way, when you come across it again, you can use the same solution. You don't have to go look around for the solution. And then for 20, what command do you use to display the information to diagnose DNS infrastructure? That will be Nslookup. And the domain name server, it might have many of the child. So that's why it's called really an infrastructure, is because there's hierarchy, there's a lot of different functionality with it. So when you see something like this, I'll type it out for you. So when you see something like this, Like, let's say B1 dot, let's say, or even on your mail, student dot email dot rccd, like that, dot edu. So the parent domain, the main domain is rccd.edu. And then the subdomain is email. And then the grandchildren of the main one is the student, like that. Okay. So basically what they have is they have a domain, and inside that they use a subdomain for email, and then inside that they would have a child domain of the email that's going to be for student, and it could be, you know, the other one is for other areas possibly. So that's how you look at it. Okay, so this is the parent, the child, and the grandchild. So that's why you see it as hierarchy. And the way that we look at the fully qualified name, right? So all of these servers are interconnected when you set it up. Any question? Okay, so I'm going to spend a little bit of time to talk about the lab and give you some time to finish the lab and take the quiz and play the review game. And in the last class, Jeff, or he goes by Lee, Jeff Dixon got the prize. So I sent that out to Jeff like the next day after it was done. So hopefully one of you will win, and I will send a $25 Amazon e-gift card to you if you win. Okay, so the highest score will get that. And you can get extra credit with that. Okay, so that is this. All right, so let's talk about the lab for this week. Okay, it's best for me to not be on it while you're on it because it slows down everything as we're on Zoom. So I'm going to try to like go through some of the steps to kind of talk to you about it, explain to you what it does, so that way you can do it, you can learn as you do it. So this is the last one for this class in practice lab, and then we will use some of that in some practice lab will be used in the other ones for some part. But this lab is really cool because as some of you have never used network sniffer or monitoring tools before, this gives you an opportunity to do that. If you want to install it, you can use Wireshark, right? You can go to Wireshark website and you can download it. And it scans wirelessly. It can scan Bluetooth. It can scan, you know, your wired network. It's a good way for us to check to see who's on the network. Wireshark is a good tool that way. And it's free. So in this lab, sorry, my server just popped open. They have that default on there. We are going to use a virtual machine, and we talked about these virtual machine being available. You notice that they added more virtual machine because, you know, that way we can have different instances with different virtual machine. So you're using Server 2016 again, some part of the lab last week. You saw some of this when you were trying to configure connection and firewall in the last two labs. So in the server, you're simply going to use the SAO1. When you power this on, if you have the pop-up blocker, it's gonna block it. So make sure that you enable for practice lab. And once it gets started, you're gonna use a Wireshark. And once you install Wireshark, it shows a little fin of a shark. Okay. By default, if you don't change the desktop option, it shows it up there. Now, when you scan, it's gonna give you a lot of different ways to filter our result. Is it ideal to leave this running on all the time in a large network environment? Sure. But what you want is really to really analyze the network. We can simply just take a snapshot of it and see what's happening. And we can run it for, let's say, an hour or 30 minutes or even less, a few minutes. Otherwise, you're going to get a lot of data. Okay. So here's the Wireshark. And server manager is going to pop up by default. It's always going to pop up. And what you can do, just minimize it. Okay. So notice that they have 2 adapter. So at home, if your system have multiple adapter, it's going to see that. Okay. So you can tell it which adapter to use or use both. So a way that we can do this is we can change the option under capture. Okay. And it would show up like this. If you check it, that means it's going to use it. If you uncheck it, it's not going to use it. So they tell us to uncheck the Ethernet too. So if you have like 4 or 5 adapter, you can select the ones that you want to use. So the internal, that will be, you know, like the network interface card that came with the motherboard, right? And then they have one that's they added. So when you click start here, it's gonna listen, it's gonna sniff out all the traffic that's on that network at that moment. Okay. And I'm not getting responses because we're zooming and see. So it's a little slower than when I did this before. It's very fast. So let's say that you keep this running for a little bit. So all the data is passed through and you see it. It shows you where it's coming from and where is it going. As I mentioned before, when you see the 255 addresses like that one, that's really a broadcast address, and that's usually used with network appliances, okay, or server. Okay, so you see a, you know, and it's color coded. Now, if you want to know what your kids is doing, you can simply run this and you can see what website they're visiting, what kind of things they're downloading. So it smells out all the traffic. It sniffs that out. Okay. So I'm going to stop it. I'm going to pause it. The lab have you keep on going for a while, because now if you, let me see if I can pull, you can always change this panel, dragging it down.
Question.
Yeah.
But if my child has VPN on her tablet, I can't see that, right?
No, yeah. So if she's using VPN traffic, you will see the VPN traffic that's coming through. You can't really look at the packets inside that traffic, because it's VPN, that the service that you have, that she has, it's connecting through a you know, a proxy, and it's going to send that through their own encapsulated channel. So it would tunnel it. So yeah, you can't really see the inside of it, but you do see that coming through. Okay. Yeah, that's not like it's stealth or anything. It's still sending traffic. It's just we can't see inside that traffic what it is. But other traffic, we can look at the packets and we say, oh, that's, you know, so even encrypted traffic, we can still see it. And in some encrypted traffic, you know, the attacker, they're very smart. They can scan, and when they look at the traffic, they will try to capture some of your session key, and they use that session key to mimic your traffic. And that's the whole point. It's not about breaking encryption. It's about using what's already been used to get a hold of that traffic, to do, you know, man in the middle, to intercept it. So so this is a common tool to use on both sides, defender and attacker. Now you can also search for HTTP or HTTPS, right? So if we do a search query, what that the filter query, what that will do is it's gonna give you that protocol only if it finds it. It does take a little bit. Or you can just hit the protocol tab to sort it, to organize it by protocol. And in a large network, this is helpful to categorize it. It's easy for us to see. Okay. So you can search for specific ones once you have it captured. You can save it, and it stores as a PCAP file. And PCAP file is used in other network monitoring tools too. So you can capture it in this application and you can import it into another network monitoring application. And when I teach forensic, we use Network Miner. It's a good tool to analyze or to do network forensic. And it does a better job at telling you who that person is, what username that person has, what, so it's very clear. But it doesn't do as good of a job in capturing traffic. So I would use Wireshark to capture and then take the file and then open it up in Network Miner, which is they have a free version of it. And then you can see. So when you're looking at malware coming into the network, you would use forensic tool like that, like see where that is really coming from and which user downloaded that malware, right? Or which user clicked on that link that fished their information. So you can find out a lot. Everything the network administrator sees. So there's no way to conceal it. Even if you use a VPN, they know which VPN you use. So, okay. So I have one of my former students, he does this for a living. He's now the director at USC for security. He did a lot of like ethical hacking and stuff for his days. And he was getting paid a lot. But he was telling me that he has teenagers and, and he tried to block them and they find proxy to connect to. So it became a challenge for him. So he would consistently monitor their traffic. And you can do that for users. But you have to also respect people's privacy too, right? In a workplace, you can do a lot, but sometime at home, you want to respect your family member with their privacy. So
Question?
what? Yes.
How did the teenagers, are they able to find a free proxy? I mean, how does that work?
Yeah, so they were able to find local proxy and they were able to connect to it because he was blacklisting some of the connection point that they were connecting to. And so even on their smartphone, but yeah, they got around it. And a lot of the kids, they find ways to do that, to get around things.
Is that outside the internet service provider?
Yeah. So wow. Yeah, so they were using their phone and they tether it and then they connect it to another proxy. So he found ways to lock their phones now, but he was telling me the challenge he was having. He said, I never had this challenge at work. I just have this challenge at home, which is ironic, right? So, they are very creative, which is good because it pushes them to learn. Okay, so let's talk back about the lab. So once you capture the traffic, it has you evaluate the traffic and filter it. And then you will look at specific port. Okay. Then you're going to create traffic. So when you visit a website, it generates the get and the get on the HTTP. It has to be able to acknowledge that with HTTP. So you have to go to the web server respond back, so it will have some reply. So here what they do is they have you visit CompTIA.org, which generates HTTP traffic. And then once you do that, it would you can verify that it's port 80. And unfortunately, I'm unable to show you everything because it's crawling for me on my virtual machine. But so once it shows here, you would see like the HTTP 1 GET. And when you open up that packet, you're gonna see the header, right, where it's going to, what IP address is the destination. Very cool. Then what you have is you have so you're gonna see the HTTP GET. So every website that your family members visited at that point, when you capture, you would see it. You would see, you know, at least the addresses, and you can find out who they are. And then what system is accessing that, okay? So Network Monitor or Network Sniffer is really useful in looking at traffic this way. So it's having you look at the port, and then you would use it again. So what they're doing here is they have you use it, monitor it, and then you're gonna filter that. You're gonna block it on Windows Firewall. So in the second part, it have you look at the HTTPS. Okay, so you will visit the website that's using HTTPS. And the creator for this company, he's from the UK, and he hires a lot of the curriculum developer that's from the UK. So you do see they talk about like the UK website. Okay. But yeah, you would go to https.google.com, and then basically you generated that traffic. Okay. See? Now, when you look at the URL, the port number is following it by the colon. So when you see like 8080, that's the port number. 443 or 444, that's also used for HTTPS. Port 80 is for HTTP, so you see the port number there on the URL. Okay. And remember we talked about TLS, so TLS is used with HTTPS. Most, like the majority of the time. Okay. So once you have that, they have you configure the Windows firewall. Like last week, you did it on Windows 10, and you saw somehow you can set up the inbound and outbound traffic. So let's say that you have your children using your Windows 10 system. You can create firewall rule to block them from certain website or certain service. You don't want the kid to game so much. You can block that port, right? Because on some gaming website, they would use specific protocol to be able to connect to the game engine and whatnot. You can block that, right? So here it walks you through on how to set that up.
Question?
Yes.
For that example you mentioned with the tethering, I mean, that sounds like a good idea as backup if your internet service provider goes out to use the tethering, but wouldn't you have to have like an unlimited data plan to use that? Okay.
Yeah, and most company now cap that as, 2 gigs, but you know, if you have, I have truly unlimited with T-Mobile because I've been with them for a long time. So every time that I change phone, I just tell them I want a grandfather in on that, and they let me. So but I don't use up all that much data even when I'm streaming or listening to stuff in my car. So here you created the rules. Okay, so on the Windows environment, after you do this and check out your traffic, I'm not going to save that there. So this is a server manager default. It's going to pop up. Okay. And on the server manager, you can do a lot like install roles. So if you manage, you can add different roles. You see that? You can remove roles like DHCP, DNS, like what we talked about. And then these are the tools that you can use for that OS. Okay, so a way that we can get to the network access or the network sharing center is you can click the little icon on the right, which is a little computer, which shows you the network access, or you can go through control panel. But so I'm just gonna do that. And then when you click on the network, it shows this. And then you can just go to the network sharing center. And this shows their Ethernet system. So you can click on Change Advanced Sharing Center, which gives you the firewall information and the sharing resources. Okay. So here, what we can do is we can also use Control Panel to do that. And then here's your Windows firewall. Now they have it off by default. So what you do is when you change your advanced settings and set up the rule, then you turn it on. If you have it enable the rule and you still have it off, it will not work. So the practice rule, and we'll talk about this more next week, is that it's easier to allow than to block, right? So what you can do is you can, what they call is whitelisting, and whitelist means that you give them a list of allowed website or allowed ports, and everything else we're gonna block. Because if you blacklist, when you blacklist, you block some of the things, you always have to keep adding. Like what I mentioned, Andy's children, they found ways around things. So now when he was blocking, he ended up just having to keep updating his list. So what he ended up doing is that he ended up using a tool that's going to control the mobile devices, but he ended up allowing them certain websites. So for example, they like watching YouTube, add YouTube to the allowed list, right? Or you enable that port for use, port 80, port 443. So here it shows you how you can set up inbound rules, and we can make a new rule. In the new rule, you can specify the port by its number, okay, which ties to your protocol. Okay, so I can say port 80, port 443, port 8080. Okay. Now, sometimes people would have port forwarding set up, for example, like for surveillance camera use or for other things in the network. Then what you have to do is you have to specify the port and the forwarded port as well. Okay. Any question? So the exercise walk you through on how to set up the firewall. Once you have set it up, you turn it on. Then you're going to test it, right? You would go to the website that used those ports. If it blocks it because you have it blocked, then it works. If it's still not blocking it, it enables it, then it didn't work. Okay. So you misconfigured somehow. So in the lab, they have you do that block connection. See that on step 8 on page 4. And then you would specify the rule name, save it. And we want people to use HTTPS actually. But in some companies, they don't want you to access the internet to go look around, so they can block it. And then you can set up outbound rule. So not that we have to set up what's being accepted in, we have to set what's going out. So you have to set both for it to work. Okay. And this is part of the job for security people, is to set up rules all day and then look at logs all day. But you get paid doing it though, right? It's not like the movies where thing flashes through your screen. The only thing that flashes through your screen is log lines, text. So I always joke around, I tell my students, it seems glamorous. And then there's ethical hacking job, but still you're gonna look at logs, you're gonna look at, you know, system configuration. So that's the job. Questions? I see some chat question. Oh, just okay. So so all of this is to show you how to set up your firewall rules, set it, enable it, and then test it. Okay, so it should show at the end that you can't connect to the proxy. And there are so many, there's public proxy too. It doesn't have to be company's own proxy. I remember my former student, he told me that at his school district where he works, they blocked YouTube for the students. And so when they set that up, yeah, the kids, they found ways to get to YouTube without going through the school proxy. And then so they have to then whitelist everything instead of blacklisted. So, okay. And then you will run Wireshark again. So for the rest of this, you're going to use the tool, change the rules, scan your port. Okay, you're going to connect directly with one server or another. So here on page 6 is where you're going to use Windows 10. Don't forget. Okay, because they look kind of similar, but you're going to use your Windows 10. And then you are going to scan. So after this exercise, you guys should know how to use your Wireshark to set up your firewall rules after you scan. And then you can ping. Okay. Any question? So I want to give you time so that way you don't have to take outside class time too much to complete this lab. No question? Don't forget the quiz, the extra credit, and the survey that you receive an email from MVC. Once you finish the module, please do my survey. That's for the performance evaluation that I have coming up in November. Okay, I will be online still. If you have questions, I'll take questions next. If you want to get off and complete your lab, so you have more bandwidth, you're welcome to do so. Have a great weekend and thank you so much for a fun 4-week in networking.
Do you want us to type our names in the chat?
Sure, you can do that. You can type your name in the chat. Thank you. See you next week, everybody. And if you don't wanna, you wanna add the class, email me.
Thank you, teacher. See you weekend.
Okay, thank you. You too. Bye. Bye.
Bye. Have a wonderful weekend.
You too. Thank you.
Thank you.
Thank you. So Sarah, before you get off, you still on? Yeah, you're still on. So go back to your question. Let me see. So you Sarah, you still on, right? Okay, yeah, I see you. Okay, so is there a God mode? There's just administrator mode, but the system would have the protected mode where you can't really see. But the highest mode that you're gonna get is the administrator mode. Yeah, they took that away when they redesigning the OS. So you still have the administrator, and then the system in the back still have the protected mode where you can't really access. That's at the kernel level, which is the layer that's going to control your hardware resources to allow the OS, you know, access to certain area, certain component of the hardware, like output, input, and etc. So the user itself doesn't have that. But it doesn't mean that they cannot go into that side. So there are ways that they will be able to strip it using, you know, programming and code to be able to access that side. The issue with Windows 7 when it came out with the NSA issue is NSA found a way to get to that mode. So Microsoft came back and they you know, they when they released 10, they updated some of that, so they control a lot of that now. But I want to show you, there's a way that you can look up Microsoft issues. Microsoft maintain a database of all their issues with trust. Let me see if I can find it. They're called the CEs. Let me see if I can find it for you. They moved it around, so it used to be only on one area. So when you come across like security warning and things in your event viewer, you can actually find some of that in through the vendor. Yeah, they changed some of their stuff on their website now. Let me see. Yeah, because they documented everything that would be as security issues, and they maintain a database. So that would tie back to updates and some of the patches that they pushed through the updates. Let me see if I can find it through their support. Yeah, so I don't think you can go through the protected mode any longer that way. Yeah, if I find it, I'll email it to you. And then that way you can take a look at it, but it's on all their applications. Yeah, no problem. Thank you. All right, I hope you have a good weekend. I hope that you can take what you learn in this class and protect your home network better, right? So, all right. You too. Thank you. Bye.